The discovery of an object from outside our solar system is sparking debate in the scientific community. The object is called 3I Atlas, and NASA says that it's a comet that was first discovered in July. It's currently passing through our solar system, reaching a point about 130 million miles from the sun.
An asteroid or alien technology? These are the questions swirling around a new visitor in our solar system. Scientists are hoping they'll get the answers about a puzzling piece of space rock as it hurtles closer to Earth.
The universe rarely announces its surprises. Now and then, a traveler refuses to fit our expectations and forces us to look again at what we think we know. This film follows one such visitor, an interstellar wanderer, named 3I Atlas, that has turned a routine comet watch into a scientific cliffhanger. As it sweeps past the sun, it is testing ideas about chemistry, motion, and even the faint possibility of something artificial. Stranger beyond the stars. 3I Atlas is only the third confirmed object from another star system ever seen passing through ours. The 3I marks it as the third interstellar visitor, after 1I/oumuamua and 2I/Borisov. Like them, it is not gravitationally bound to the sun. This is a one-time pass through our neighborhood before it returns to deep space. From the start, it refused to behave like a typical local comet. Pre-discovery images showed 3I Atlas already active far from the sun, where water ice alone shouldn't drive jets. That early activity hinted at more volatile ingredient substances that vaporize at colder temperatures. As the James Webb Space Telescope, the Hubble Space Telescope, and major ground observatories observed it, the object kept breaking the mold. Its path is a clean hyperbola cosmic shorthand for just visiting. It rushed in at about 58 kilometers per second relative to the sun, faster than either oumuamua or Borisov. Near perihelion, its speed climbs to roughly 68 kilometers per second, a reminder that even the sun's gravity can't capture a traveler moving this fast. After it swings around the sun, it will head back out, carrying its secrets with it. There is no danger to Earth, even at its closest to us. December 19, 2025, 3I Atlas will stay about 1.8 astronomical units away, 167 million miles, or around 269 million kilometers. For scientists, that safe distance is an opportunity to watch a messenger from another stellar neighborhood in real time. The message is already surprising. Its speed, early activity, and unusual chemistry point to formation conditions unlike those of most comets we know. The question was never, is it odd? But how odd, and what does that oddness reveal about other planetary systems? The sun's crucible. All eyes turn to October 29, 2025, when 3I Atlas reaches perihelion, its closest point to the sun, at roughly 1.36 astronomical units, about 126 million miles. That puts it between the orbits of Earth and Mars, where sunlight is intense and surface ices face a severe heat test. Perihelion isn't just a waypoint, it's the experiment scientists have been waiting for. If the object is a natural comet with unusual ingredients, stronger warming should expose deeper layers and broaden the mix of outgassing ices. Researchers will watch whether water in the coma increases after perihelion, how brightness changes, and how dust and gas production respond as the surface bakes. Those trends reveal how the nucleus is built, layered or mixed, fragile or tough, porous or compact. A more speculative camp is watching for something different behavior that regular outgassing can't explain. During solar conjunction, 3I Atlas sits close to the sun in the sky and is temporarily hidden from many telescopes. That brief invisibility window invites bold ideas. If, when it reappears in November 2025, its trajectory shows a deviation that standard rocket effect models can't reproduce, the conversation could shift. To prepare, NASA and international partners have lined up HST, JWST, and an array of ground-based telescopes to resume tracking as soon as the glare eases. This is science at work. Find an anomaly, propose competing hypotheses, then wait for the decisive event that lets nature choose among them. For 3I/Atlas, perihelion is that event. the moment when its behavior either matches expectations for a volatile-rich comet or demands a new chapter. Beyond the drama, interstellar visitors act as probes of other planetary systems we can't sample directly. Every observation of 3I/Atlas captures conditions around another star where different ice is condensed, how radiation shaped chemistry, and how collisions built or shattered small bodies. The measurements we make in the weeks around perihelion will feed models of how planets and comets form across the galaxy. Secrets in the chemistry. Nothing has stirred more excitement than the object's chemistry. When JWST dissected the light from its coma, the spectrum told a startling story. The gas is extraordinarily rich in carbon dioxide. Some analyses report one of the highest carbon dioxide to water ratios ever seen in a comet, interstellar or local. If ordinary comets are often described as dirty snowballs dominated by water ice, 3I/Atlas looks closer to a dirty dry ice ball, with CO2 playing a leading role. That composition carries big implications. It points to a birthplace far from its parent star, beyond the CO2 snowline, where carbon dioxide freezes into solid grains, or to a high radiation environment that favored preserving CO2 while altering other molecules. Either way, 3I/Atlas bears a chemical fingerprint from another planetary family, direct evidence that the raw materials of worlds vary widely across the Milky Way. Ground-based telescopes added more clues. Observations from the Very Large Telescope in Chile detected cyanide, a common comet tracer, and something rarer. Vaporized nickel appearing without its usual partner, iron. In most comet studies, nickel and iron show up together in similar proportions. Finding nickel alone is unusual. It doesn't prove anything artificial, but it highlights how interstellar comet chemistry can be more exotic than the patterns cataloged in our own system. Taken together, the findings point to a nucleus built from ices and grains, formed under conditions different from those near our sun, perhaps a disk with other temperature gradients, pressure profiles, or radiation histories. Each detected molecule is a clue to that original environment, how cold it was, which gases were abundant, and how small bodies accreted and evolved before being ejected into interstellar space. In that sense, 3I/Atlas is a bottled sample from a distant neighborhood. Tales and mysteries, comets announce themselves with tails, plumes of gas, and dust, shaped by sunlight and the solar wind. Usually those tails point away from the sun, but in July and August 2025, 3I/Atlas displayed a striking sunward feature, a plume apparently pointing toward the sun. This anti-tail sparked debate. Anti-tails are rare but not unheard of, often caused by perspective and alignment of dust sheets that makes a tail appear sun-facing when it isn't. In this case, modeling suggested something else might be involved. One idea is that jets of volatile gases like CO2 lofted large grains of water ice. Big grains feel less radiation pressure than fine dust, so they can briefly form a sun-facing plume before normal dynamics restore the usual geometry. As September progressed and sunlight intensified, the odd plume faded and a standard anti-solar tail dominated. That sequence, a sunward structure followed by a normal tail, offered a clean laboratory for testing how grain size, gas composition, and solar illumination interact. Seeing such behavior in an interstellar comet makes it even more valuable, hinting that dust-gas physics can play out differently in other systems. Motion added more intrigue. A comet's path is governed by gravity, but jets of sublimating ices act like tiny thrusters and can nudge the orbit a non-gravitational acceleration. 3I/Atlas shows evidence of these subtle pushes. How strong are they, and do standard outgassing models explain them? Small mismatches matter. They can tell us how mass is distributed inside the nucleus, how active areas are oriented, and which volatiles are driving the jets. These anomalies, extreme speed, odd chemistry, the sunward plume, and hints of non-gravitational acceleration have encouraged a fringe but lively speculation. Harvard astrophysicist aviloeb has asked whether 3I/Atlas could be artificial, a probe, or even a mothership. He notes the timing. The object's most critical solar pass coincides with solar conjunction when it's hardest to observe. In that scenario, a spacecraft might attempt an Oberth maneuver, firing engines at closest approach to maximize efficiency, perhaps to slow into a bound orbit or release smaller probes, all hidden in the sun's glare. The scientific consensus remains that 3IATLUS is natural, highly unusual, but natural. The chemistry, though striking, has plausible origins. The tail behavior can arise from grain size effects in viewing geometry. The extra push on its path is expected once the right volatiles are sunlit. Speculation isn't dismissed, but it must face the same standard as any hypothesis. Extraordinary claims require decisive evidence. That is why the days around perihelion and the weeks afterward matter so much. When 3IATLUS emerges from behind the sun in November 2025, a global network will pin down its position, velocity, brightness, and spectrum. Does the trajectory match predictions from gravity plus outgassing? Does brightness evolve as deeper layers heat and vent? Does the molecular mix shift as the surface changes? Each answer will either reinforce the natural picture or point to something unexpected. Discovery is not a straight line, but a conversation between evidence and imagination. This is how we learn, this is how we grow, and this is why a speck of ice, dust, and mystery can change the way we see our place among the stars. Thanks for watching. Don't forget to subscribe to Epoch Dive for more amazing documentaries.